Hi, let's make a Flappy Bird.
Okay guys, and before we begin, I would like to show you what are we going to achieve after this brief tutorial. And as you can see, it is a very profound example of Flappy Bird clone. It has all the mechanics of Flappy Bird, which is it being floppy, it scoring points, it being amazingly difficult, it being borderline rage quit game. Yeah. If you want to hate yourself like I do, then go not only create it but then play it for some seriously long sessions. Alright, without further ado, let's jump into the creating part of the tutorial. Okay, so obviously we start with creating new Unity project. We'll call it Flappy Bird. We press create. Wait a varying amount of time depending on your hardware, I believe. I don't usually do that, but this time I believe I hit my rock bottom when it comes to laziness, and I didn't create my own set of assets, meaning the sprite sheet. And so this time I decided to use the classic sprite assets we can find on the internet when we Google for Flappy Bird sprites. And then we choose the very first entry in Google search, and when we open the graphics in the new card, we can see there's this 512 by 512 pixels wide sprite sheet with every assets we'll need. So we save it. In the assets folder of our game and return to Unity. After the project refreshes, we've got our imported sprite sheet. We changed the type to sprite 2D and UI. We go to multiple and we change the filter mode to point no filter. We change the compression to none. Hit apply. We need to go to package manager. Wait a moment, search for 2D. Wait a moment. And download this 2D sprite. Install it. We don't really need internet connection to do that. Okay, when it's done, we open Sprite Editor because we have already installed this utility tool. Don't change anything, just go with automatic and slice. Everything will be matched correctly. The things that we will use will be matched correctly. So, well, that's it. We hit apply and close and forget about it for the moment. Let's change to 2D. Let's go to the main camera, change it to solid color, make it darkish, not black, but darkish. And I have experimented with different sizes of the orthographic camera, and to be honest, 1.3 will do the work if you use this kind of asset, this particular asset sheet, because as you can see, we'll create background. So let's create empty, call it background. And then here we'll add a sprite, and here as a sprite we'll put the background. Let's reset the position of the camera to 0, and as a matter of fact it's a bit cut, so the main camera will go to 1.2. It would be better. Alright, so we've got our background called background, and yeah, now we've got the resolution working. Let's create a 2D sprite which we will call player. Let's add the sprite of the Flappy Bird, and I will choose the blue version. Doesn't really matter. Alright, so far so good. Let's deal with the idle animation of the bird first. So we go to animation, we go make sure the player object is selected. We go to animation. Let's make it a separate window. Not here, but in the scene view. Okay, we create first animation, we call it idle. Let's put it to folder called animes. And we save it here. We've got this idle animation. And first of all, we need this image, this sprite. Then we need those two other sprites. And as a matter of fact, in order to make it look smooth, we need to reverse the order. So we've got 5 sprites. There are 4 periods between them, so it's best to choose time which is a multiple of 4, such as 16 second, 0.16 second, or 0.28. I mean 28 milliseconds. That's what I meant. Then why is not working? Okay, let's move it by hand. Okay. As you can see, it's quite slow, pixelated, but it is smooth, and that's what we wanted to achieve. So make sure that all the periods are the same length, and also we have the same frame at the beginning and at the end, because without it there will be a bad effect. Okay, let's put the animation here, hide it, we don't need it anymore. When we go play the game, one more thing, let's put player as order 2 in layer. As you can see, the player is being animated correctly. You can make it faster, you can make it slower, to your liking. Right now let's deal with controlling the character. So in order to do that, let's add a component, we call it player controller. Let's open up it in Visual Studio. One more thing, we need to add obviously rigid body 2D, and also let's add a circle collider 2D. I believe it's better to use circle collider than box collider here, because the bird is more of circle sized. And let's make it a bit smaller, something like this, so that the movement is smooth and we do not catch places like this box of selection, as you can see, because it would feel like an unwanted behavior when we use boxed collider. And right now, when we got rigid body, let's decrease the gravity scale for the moment. However, it's something that you would have to tweak. I can show you some values I use, but as a matter of fact, it's a guessing method. So first of all, we need this rigid. We need to catch the rigid body. Call it player body. You can catch it in the start method. So player body equals get component rigid body 2D. That's a method. All right. Okay, so we've got already the reference. What we need now is a float of force value. Let's set it to 100. Sorry, 100. You can make it public, so you can alter it inside the editor. However, the value of 100 should do the trick, as far as I'm concerned. Right now, what we want to do is to add this force to the player acting upwards, so the bird won't just fall into void of what's below the screen, but we need to have a possibility to, act, to play. So every time we press mouse button, left mouse button, or a tap on screen, however, we are now creating a PC version of this little game, so let's stick to the mouse input. So we go with very simple if input get mouse button down, because we need only to register the press, not whether we are holding. We go with player body at force, and we go with vector 3 up and times force value. As a matter of fact, that would be it when it comes to as you can see, we are playing with the gravity here. So whenever I press, the bird goes up a little bit, and the motion is calculated with the physics engine, so you don't need to worry about anything. Right. And always the bird is in the middle. In this scenario, it will be always in the middle, so there's no point in changing anything when it comes to the horizontal axis in terms of movement. Obviously, you can change the force to be a little bit smaller and the gravity to be a little bit also smaller or bigger, whenever you want to have a feeling that the gravity force should be acting more or less powerful than the one I'm showing, but that's to your liking. Right now what we want to do is we want to create a infinite scrollable background and foreground. First, let's make background because it's easier, and the same thing will apply to foreground. So after we are done with one, we can switch to another quickly. Let's make a background logic. I call it background logic, but as a matter of fact, can be called background movement or like whatever. One more thing, before we go any further, let's create a game object. We call game manager. I like this this thing and let's attach game manager script to it. It's a nice organized way to hold important values. We don't need those two methods, so we delete them, and let's create a public static bool is playing, and let's set it to true, so the game is on. All right, and then we need two more values for the time being, at least, which will be public float, public static float, obstacle velocity, and we'll set it to 0.2f, and also public static float background velocity, and let's make it 0.01 f. Right, and also we can go with public static int score, and it's set to 0. When we go to player controller, let's make sure that our input will be taken into account only if the game manager is playing is true. So we add this little line here, so whenever it's only when it's true and we press mouse button does our player character move, because otherwise it shouldn't, and that's what we want to do. So we go to the background logic, and as a matter of fact there is not much to do here. The only thing is we don't need the start method, it's just trash. So we have an if condition statement. We check whether we are playing, so it's whether it's not paused or a lost game. Then we go with this game object and its transform and position, and we just alter it by setting it to the previous position plus new vector, which is the iteration step, game manager, background velocity times time dot delta time, and then 0 and 0, because we don't want it to change the value at y and z axis and z axis, only at horizontal x axis. Right. One more thing is we want it to scroll infinitely. As a matter of fact, we need to put minus here because it will go the other direction otherwise. Alright, and as we can see, it will move slowly towards the left side of the screen. As you can see, it is moving. However, the problem is that when it moves, it won't stop moving. So first of all, let's create other iterations of this background. So let's duplicate it 4 more times, and then, as I believe, let's put it to 1.4 position, 2.8 here, minus 1.4 and minus 2.8. And right now let's do something with the border of the movement. So whenever we hit transform position X, whenever it's smaller than -3, we want it to be reset to position X, or no, because new vector 3, and the X value will be 3, the rest values will be 0. So whenever any background will, let's go to the scene. In a moment, this background will hop to the very beginning of the screen, but it needs some time still. Yeah, and right now everything will move smoothly, which is fine. Yep. Alright, so that's it when it comes to background. So we've got our background scrolling infinitely, so we can collapse this, and let's create a new object. We call it obstacles, and here we'll create an obstacle. I know, that was quite a surprise. Let's use the green pipe. I also always wondering whether it was not stolen from the Mario Bros franchise. I mean, in terms of like, you know, plagiarism when it comes to this pipe, but whatever. All right. What we want to do, let's rename it to obstacle, and let's create another sprite here. We call it upper obst, which stands for obstacle, obviously. And let's move it to 2 or 2.5. Yeah. Right now, what we want to do is we want to have, where's our player? 0. Oh yeah, we need to reset this one. I'm always wondering why when we create a new object, its position is set to like very random values. I have never bothered to check why is that, but well, that's one of the things I dislike in Unity. Okay, coming back to the obstacle. So we've got this obstacle object, and what we want it to do is to go from the right side of the screen to the left side, just like the background, whenever it's outside the boundaries of the screen, it should reset its own position to the very beginning. And so forth. But one more thing is we want to reset the position of the obstacle in terms of the vertical axis, because right now it's bad because the bottom pipe is too high. So if we do some number guessing, we can see that 0.5 minus 0.5 is the biggest applicable value, and minus 2.5 is minus 2 is the smallest applicable value. So we'll be guessing, we'll be choosing randomly value between minus 2 and minus half. Yeah, so we'll be making this kind of passageway and gate for the player to aim for at every like this pair of pipes. So let's create a obstacle logic script. As a matter of fact, that's the last script we'll need. So 4 scripts and like less than 100 lines of code, I believe, to recreate this great piece of game. All right. At the very beginning, let's randomize the position. So we go with new vector 3, transform position.x, and when it comes to y, it will be random.range, and it was between 0.5f and minus 2f. Sorry. Oh yeah, all right. It doesn't really make a difference. As a matter of fact, I've put bigger number as minimum and smaller as maximum, and it's wrong mathematically. However, I've noticed that when it comes to this particular function, it does not matter, which is kind of funny when you think about it. But as they say, it's not a bug, it's a feature. Okay, so in the update method, we check whether we are still playing the game. If we are, then we want to change the position to, maybe not this, to transform position plus new vector, and here once again we'll call minus game manager dot obstacle velocity times time dot delta time, and here 0 and 0. All right, and if our transform position will be transform.x position x will be less than minus 3, we will transform position equals to new vector 3. Once again, we'll randomize the value. So let's copy this one here, and bracket, and that's it when it comes to this funny stuff. One more thing is we can do several obstacles in 2 ways. One is to create, to hard code somehow like 5 or 6 obstacles, because they will iterate, and I mean not iterate, but they will just move to the forward anytime they move out of the screen. So we don't need actually any game manager logic to keep track of those obstacles. And in this particular game, I recommend you do it the way I do it because it's easier. However, if you want to have more freedom and more control, then go to Game Manager and then implement some stuff concerning spawning and destroying objects or pulling them. So yeah, up to you. But if you want to create this little project as I do, then just go to the obstacle we have. And remember to have this obstacle script on the obstacle object, not on this like family, on this mother game object which just holds all the obstacles in order to have like clear hierarchy. So on the obstacle we've got the obstacle logic, obviously. And one more thing which I forgot is we need a box collider to the obviously on 1 and on 2nd, because well, that's what the game is about. The point is not to touch those obstacles, so we need a collider for that. And when we press play, and if we do not forget to change the order in layer to 1 so that it always is above the background, we'll see that it is moving to the left side of the screen, and whenever it is very far outside of the visible area, it will be moved. And as you can see, it randomly changed its position in the vertical axis, which is also good because the game will be randomized. Let's create 5 more items, and let's move every one further away. And this one we'll put to 6 because we don't want to start inside an obstacle. You can actually move them even further away, all of them, so that you will have this period of getting into the game before the obstacles start to show up. But well, right now, as you can see, there's a mistake in value because that's not what we wanted to achieve. Okay, turns out I forgot it shouldn't be 2.5 but 2, just 2 when it comes to the limits. So it will be maybe this one, between 2 or -2 and -half, and it should be doing just fine right now. Okay, and as you can see, you can already play the game, but yeah, physics. We don't want the bird to rotate, so let's go to the player, to rigid body, constraints, and freeze rotation. Also, I want to decrease the gravity scale even further to 0.2 or even to 0.1, but okay. Right now you can already play the game as the author initially intended, but there's one more thing to do, is to create the game logic. So we want to get some points and also to have the possibility to lose the game. So we'll go to the player script, or maybe first we go to our obstacle logic, and let's create a bool we call rewarded. Let's set it to false at start, and in the start method we want it to be set to false for the sake being false. And when our transform position x is less than 0, so it's in the middle of the screen. Then we want to have our game manager score to be increased by 1. And also here we change the rewarded to true. And here in the if condition we check that we only reward it once. So we check whether the rewarded is a false. This exclamation mark means if rewarded is false, this one will be treated as true. And when we set it to true, it will be treated as false. So it will not give us points more than once, only once. Because after we pass the 0 position, so this threshold, without this condition, the second condition, will receive points every frame. So like at least above 60 times per second, even 200 times per second, which is like not something we intend to do. All right, and in the game manager, let's create a update method actually. And here, but first of all, we need to have a TextMesh Pro text. We call it score text, and we need to import using TextMesh Pro. We'll make it public, and here in the update we will not transform but text equals to something plus score. And yeah, every frame, I mean, we could actually update it only whenever we increase the number of points, but we can also do it the easier way, so just increase it every frame. In order for that to behave well, we need to create UI TextMesh Pro. Then we've got this little pop-up that we need to import the essentials. For the TextMesh Pro, we do it. We don't need, and we import also the extras for other fonts. We don't need internet connection for that, and as you can see, it's going pretty fast. And yeah, let's make it 100. Don't worry about how it's behaving, because that's a very normal thing. So you can see here we got the canvas, and we want I want the score system to be in the middle. Sorry, in the top left corner. Doesn't really matter where it will be. Let's make it middle center, wrapping disabled. Let's make 10 as the default, and let's put it to 50 and -50. Let's change the font to, yeah, bangers. Can be bangers, really. Doesn't matter that much. And remember to go to Game Manager and put this TextMesh Pro here. So, as a matter of fact, as you can see, we've got 0 points, and whenever we go through any of those gates, we receive a point and we increase our score, which is great, to be honest, because that's what the game about. It's about scoring points and getting highest score and playing with this Flappy Bird. Very exciting gameplay. In order to make it a little bit difficult, I mean more difficult, not really more difficult, but in order to have the difficulty level to like scale with time or something, here in the update method, I would suggest you do something like this. So we go with obstacle velocity, and we'll increase it every frame by value 10 times smaller times time.delta time. So every second we will increase it by 10th of the initial value. So after 10 seconds we'll have the double speed. After 20 seconds we'll have triple speed, and so forth. The same way we want to apply to the background, so that it scales in pair, so it's connected and it's very consistent this way. That's the scaling. One more thing, we go to our player controller and we need to put one little function which is pre-coded, we just need to call it, and it's called onCollisionEnter2D. Here we go with game manager is playing equals false. And as a matter of fact, that's it when it comes to registering the collision, because we are not really doing anything more than just checking whether the collision occurred. If occurred, no matter what collided with what, because it's always the player colliding with something which is an obstacle, which is fine, and we are not playing any animation, we are not popping up any menu, so that's it. We just change the value and then nothing is being calculated and moved and so forth. Just one more thing is we don't need and we don't want actually our player to go outside the boundaries of the screen. So here in the update method, before or after registering, maybe after registering, it doesn't really matter, but we will check whether the transform position on the y-axis, if it's not bigger than, and we can go and actually check what's the value, what's the threshold, depending on the screen size, on the resolution and like everything. So as you can see, 1.25 and minus 1.25 are the values. And let's reset it to 0. So if it's bigger than 1.25 or transform position y is smaller than minus 1.25, then we go with game manager is playing equals to false. And that's it actually. So not only we lose when we touch the obstacle, but we also lose when we go outside the boundaries of the screen, which is good. Let's play it once again and enjoy our little game. Plop. 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 It's going faster and faster if you notice it. 4 points is my high score in this game. Also, we could make a little high score mechanic, which is not that difficult. I'm really bad at this game. However, the video is not about me showing you how to master this game, because you can find a lot of tutorials on that. I wanted to show you how to create this Flappy bird in Unity, and that's what I did. I feel proud. You should feel obliged to subscribe to my channel, and I believe that's a good deal we are having here. Oh, that's a bad playstyle on my behalf. Alright, thanks you guys for watching, and if you want you can find if you want you can find the code on my repository that's available on my Patronite. And when it comes to the assets, link to the assets sprite sheet can be found in the description of the video. Alright. Once again, thank you guys for watching, and see you in the next tutorial on whatever I'll be doing in the next tutorial. So, cheers!